On this problem, we're given two different lines, and they're represented by ordered pairs x and y. So we have two ordered pairs for line 1. We have two ordered pairs for line 2. And it wants us to give a line, it wants us to define whether these two lines represented by these two ordered pairs are either parallel to each other, perpendicular to each other, or neither. So again, what we want to do is just remember, what do parallel lines have in common? And when we talk about parallel lines, one thing that they'll have in common is m, in other words, the slope is equal. Or we could also just say the slope is the same. So this is going to be really simple. If we want to find out if these are parallel, we just need to find the slope of both lines using their ordered pairs, and then we can determine if they're going to be equal. And if the slope is equal, then it's definitely parallel. On the other hand, when it comes to perpendicular, I'm going to put a star by it. If the line is perpendicular, we can also tell by the slope. It's very unique because in that case, m is going to be what we call the opposite reciprocal. So opposite reciprocal. And the opposite reciprocal means, just for example, let's say, let me use a number that's real easy to see that it's a reciprocal. Let's say we had -3/8. Let's say m was equal to -3/8. Okay, if it's the opposite reciprocal, then if we looked at the slope, the other line slope should be the opposite sign. So instead of a negative, it's going to be a positive. And the reciprocal means that we flip the numerator and denominator. So it would be positive 8/3. So this is just an example. I'm going to write example. If the slope of one line is -3/8, the slope of the other line should be positive 8/3. Now, if we don't see either one of these situations, if we don't see either an equal slope between these two lines or a slope that has the opposite reciprocal, well, then we're going to choose neither, right? Because it's going to be neither parallel or perpendicular. And we're also going to graph these lines to be able to look at them. But let me show you how we do it mathematically first. So mathematically, I'm going to go ahead and use my formula for slope. My formula is m is equal to y2 minus y1 over x2 minus x1. So I'm going to substitute my numbers. And when I say substitute, let me just draw another fraction bar. I like to call that a fraction bar, right? Our division symbol. And for y2, I'm actually going to just put a set of parentheses. And then I'm going to put a subtraction sign. And then my y1. And then for the x2, I'm going to put a set of parentheses minus my x1. And we just have to label some points. Now I'm going to box it with line 1. Let's do line 1 first and see what the slope is. Now this is going to be I'm going to label this. This is my x1 and my y1 value. And this is going to be my x2 and my y2 value. That way you can see where I'm pulling my numbers from. So for y2, right, because it says y2 minus y1, my y2 value is 9. My y1 value is -1. And then for my x2 value, it's positive 5. So x2 goes first. And then my x minus my x1 value. In this case, it happens to be 0. And we just need to put this in the calculator, and we'll see what our slope is. So I'm going to put this is my m is equal to whatever this is. Now, we could do that by hand, right? It's not a problem. However, why do it by hand when we have a calculator? So I'm going to come over to my calculator real quick, and I'm just going to go ahead and put this all in. So let's go ahead and let's see, we're going to have some division going on. And in my numerator, I'm going to put in 9, close parenthesis, minus parenthesis, and then we have -1. All right, and then from my denominator, we have 5, and we have -0. So, right, so I'm going to put in 5, and then -0, which isn't going to make any difference, right? So let's just go ahead and hit, now notice it looks exactly like what I got written down. I'm going to hit enter. Actually, it already does it automatically. I almost forget sometimes this one does it automatically. And it tells me that it gives me 2. Okay, so I'm going to go ahead and write that down. So I have a slope of 2. And that makes sense, right? If you look at this, right, if we were to distribute and do this by hand, that would turn into a positive, and we would end up having 9 plus 1, which gives us 10. 5 minus 0 is going to give me 5, and 5 can go into 10 2 times. But notice I did that very easily with the calculator, right? So you could do it by hand or with the calculator. But now let's check the second line. So we're going to do line number 2. So let me go ahead and label it. That's my x value. That's my y value. That's going to be my x2, and that's going to be my y2. Okay, so we got m is equal to my y2 value minus my y1 value over my x2 value minus my x1 value. And if I start substituting numbers, y2 is going to be a 1. Y is just going to be a 3. x2 is going to be a 4. And x is going to be a 0. So, right, I'm going to just throw this in my calculator, and we'll see what we end up with. All right, and hit my division symbol, put my parentheses, and we have 1 minus, actually 1 parenthesis, minus 3. And that's going to be over 4 minus 0. And it tells me that it's negative 0.5. So let's go ahead and write m is equal to negative 0.5. So 1 minus 3 gave us negative 2, and 4 minus 0 just left us with positive 4. And that does, if we convert it, just become negative 1/2. Now, we do have our slopes, right? And we can compare them now. This slope is positive 2, and this slope is negative 0.5. Now, what you want to think about is, when you're looking at negative 0.5, initially you might have thought, well, you know what, this has no relationship. But I want you to think about what we see here. This first m is a 2, so I'm just going to draw this. So m is equal to 2. Now, every integer you see, like 2, if we turn it into a fraction, we just put it over 1. Right? In other words, 2 is the same thing as 2 over 1. And remember the rule that we had for perpendicular line? It says if it's the opposite reciprocal, it is perpendicular. So in other words, if I flip this, so in other words, I move the numerator to the denominator and the denominator to the numerator. So this goes up, this goes down. If I flip that, that would become 1 over 2. And then if I do the opposite sign, instead of a positive 2 over 1, it's a negative 1 over 2. The reason I'm showing this is because we do have a relationship here, and that would mean that these two lines are perpendicular. Because our slopes, the m value that we got for each one, m is equal to negative 1 over 2, m is equal to 2, or opposite reciprocals of one another.